Welcome to this new section. In this section, we shall train and optimize our model using TensorFlow's inbuilt Adams optimization. And then we shall go ahead to find how well our model performs by calculating its accuracy. Then we shall validate and test our model. Looking back at previous code, we had the train dataset, the validation dataset, which has been built already, then the model, which we can see right here, and then we compile this model, specifying the optimizer, specifying the loss, and the metrics. Now, the reason why we're saying here that we're using the sparse categorical cross entropy instead of maybe just the categorical entropy is because the outputs given by this tf.keras, the preprocessing image dataset from directory function is such that the output of each data point is made of the particular category to which an image belongs. So we may have y, which is going to be, for example, say the first image is the third category, the next is maybe the 134th category, and so on and so forth. So it's not a one-hot notation, or it's not a one-hot representation of the output. So that's why right here we have the sparse categorical cross entropy used instead of the categorical cross entropy. So we'll do this, take this off. All right, since we defined this initially, now we define the number of epochs. We take it to 1,000, and then we store in this history the values or the different values of the losses and validation losses, accuracies, and validation accuracies we will get. So from there, we now fit our model, which will permit us train this model. We input the train dataset. We specify the validation data, which is val dataset, the number of epochs, and then after we could save our model. So let's run this, and training begins. After training for over 100 epochs, we have the following results. We see that the loss reduces up to a loss of 0.013, while the accuracy increases up to 99.96%. But looking at the validation, it's clear that our model is overfitting because our validation loss is instead increasing and its accuracy is dropping. So we have right from here, if we step back, we saw that the validation loss decreases, and up to a certain point, it starts increasing, which is not good for our model. After saving our model, we have this plot, which is basically the train and the validation results, or the train and validation losses. But it's clear that our model needs to undergo some corrective measures. So see you in the next section.